Let me give you something to think about. If you had a short wire and you moved a magnet across it, you would always have limited potential, because the length of wire was so short. Okay, now what if we increase the length of the wire to many miles in length? Even with a very weak magnetic field moving across the wire, you still have a much greater potential flow of power available. If we put it into a perspective of power per inch, it may be easier to understand. If you have a small magnetic field moving across a wire 12 inches long, it can generate an electron flow equal to, let's say, 1 millivolt per inch. If you move the magnet 12 inches at the same speed, you get 12 millivolts as you transgress the 12 inches of wire. Understand that I am trying to convey a principle that you can understand for use in the future. So, you have a wire 12 inches long and you can make 12 millivolts moving a magnet across it. If you have a wire 1000 feet long and you move the same small magnetic field across the length of it, you can create much more voltage potential, perhaps 12,000 millivolts, let's say. So, you have managed to generate a significant amount of electric power with a weak magnetic force. Okay, how does this help us? Where am I going with this? Suppose you have 1000 pieces of wire 12 inches long and you run the same weak magnetic field over them all at the same time. You get the same flow of electrons. If the wires are run in series, then you will get the 12,000 millivolts, etc. If you connect the wires in parallel, you will get higher current but lower voltage. However, the power potential is the same, whether you run the wires in series or parallel. If you know how to find the circuit potential, you tune into the frequency and you have enough short pieces of wire, you can convert as much power as you wish in a given space. You would be fascinated with the amount of renewable energy you can extract from a permanent magnet.